make a design. And then today we did a little bit of looking into how data is collected in person. So whatever goes into calibration, validation, etc., that goes into actually collecting the data. So now what we're going to look at is data viewer. How do you visualize the data that you've collected? So say you have so many people's data, and now you want to know where they looked at, what they did. And most eye tracking experiments, if not all, are actually concerned with specific types of data in specific time bins. So suppose you had an experiment. Let's take the experiment that was discussed yesterday only. Like there is a certain time bin that you're looking for in which you want to check where the saccades have gone. So on set of maybe the screen that has come and the images, so the queue, when the queue came, from then maybe from then on till where the person gave a response. I'm hoping everybody remembers the experiment from yesterday. You want to see where the person has looked at in that time frame. So data viewer is SR Research's software that allows you to look at and analyze and extract data for a further analysis. Okay, so what you do is I'm just going to import a few files over here from one of our ongoing experiments, maybe like literacy or something. I'll pick up gaze queuing.
Yeah.
Anyway, okay, so essentially what happens is that when you import the data onto this, you can import multiple iLink files. So there is an option quickly, as soon as you go to import data, you import your particular files. You can also import interest area templates, but I will get back to that later. So in the morning when we were discussing your interest area templates, remember I said you should just usually just link it to the location of the target appearing itself, so that you don't have to go through the hassle of physically creating extra interest areas. You can do that and you import them over here using this particular option. But then, like I said in the morning, it doesn't make a lot of sense to make every variation of your particular interest area template and then physically import it onto what you have to look at. So in any case, so now you have, once you've loaded the files, once they've all been imported into data viewer, what you're going to do is you're going to select the time period of which you are interested in. So that will completely depend on your experiment. Now suppose in an experiment, for my master's thesis experiment for that matter, I did an anticipation task which had a blank screen paradigm. Okay, so there was a sound and then there was a blank screen, and I wanted to look at people's eye movements on that blank screen. So all I did was a specific amount of time before the sound came and till the sound played, and then after the blank screen got over, I selected a time period. So you edit over here and you select, you add a new time period. Oh, this is important. You add a new time period, okay? And so what you do is you give it an interest area, new interest period one or whatever. You give it a name that you want to give it. Now you can have multiple interest time periods, all right? So maybe you want to look at 1,000 millisecond bin in the beginning of the experiment, one in the middle and one towards the end. So you can have different types of time periods and you can give them their particular names. Now, how do you decide from when, or how does data viewer decide or know from when to when you mean? Right? So over here, I hope it's clear, but it says EDF message. So yesterday in Experiment Builder, we saw that we had to give messages to every single screen or every single thing that was added onto our experiment, right? This is where it becomes extremely crucial, because if you want to, say suppose you want to tag a time period or you want to tag eye movements from, suppose when your display screen appeared, okay, you know that the message that you gave for the display screen in the Experiment Builder was, say, display screen, okay, you know, and nothing else has that same message. What you can do is you can put in the name of the message. The message text is where you put in the name of the message, and then you put in your start event offset, okay. So from then, if you want to have from that particular event, if you want to have an offset before or after, you can put it in at the start event offset. But so suppose I have a display screen, okay, I will type in display screen here, and that's like doing that for me. And when I am now, if I want to like tell it where to end or what particular time it is ending over here, I can put in, suppose now I want it to end at the end of the display timer. So maybe I put in display timer over here, and it will know that when this particular EDF message has come in the experiment builder file that the trial that the experiment has played, it will know to stop tagging eye movements in that particular time bin. Or what you can do is you can click to duration, and you can go into you can just specify, suppose from the onset of the display screen, you can say 1000 milliseconds, and then it will just take 1000 milliseconds or whatever has happened after the display screen has come. So it depends on what you want, how much you want it, and eventually later what you want to downsize it to during analysis. Okay, so abhi suppose it's saying display screen, so usually you can put in a duration of whatever you want. Now you suspect, according to your hypothesis, you suspect that your particular type of eye movements that you're looking for, or your kind of reactions that you want in a particular time bin will be now. You put in that, and you go ahead and say okay. So over here it says apply strict event matching. What happens is across every single person's data, it will strictly only do to this particular event and not anywhere else. Then you press on OK, and duration must be okay, so I'll just keep going. Okay, so then it gives me a time period of new interest period 1. Alright, so then once this is done, you click on OK, and that's over. So now over here it is showing you in what time period it is. Now because this is such an empty data file, we do not have any eye movements in it, there is nothing over here, and I am also sure there is like no eye movements. There is no like maybe there is no. Oh, okay, cool. You're right here. So I'm also sure maybe there is nothing called display screen in this. So now that I have set my time period, what I can do is essentially, if there were other people's like data over here, I could look at individual trials of individuals by myself over here, just to check if there are eye movements in that particular time period or not. And if after I have gone through this entire thing and decided that fine, okay, this looks like what I want, I can go to analysis and I can go to reports. Now experiment data viewer is equipped to give us a lot of different kinds of reports. Okay, it says fixation reports, Saccard report, interest area report, trial report, sample report, etc. So depending on what you're looking for, if you want to study fixations, you might want to extract a fixation report. If you want to study your Saccards, you might want to extract a Saccard report. But typically what one extracts from this to go into, like suppose it's a visual world experiment, what you would export is a sample report. Now a sample report will have mostly everything that the that you could possibly need, but okay, so here, so it gives you a lot of options of what you want. Now data viewer is actually taking in data from the EDF results that have been generated of your experiments. So it generates a whole lot of results. Now you might not require all of them. It's not important for you to read every single one of them. So you choose in this particular column what you want. So suppose you want to know what eye was tracked, and typically you do need this because in most experiments, sometimes if there is loss of data from either eye, you can compensate for that at the analysis stage by switching over eyes. So when you're in, suppose you're using R to analyze this, you require this variable to ensure that there is data in the particular eye that you have tracked and there is no like issues with the sample report that you have. So suppose you have your eye tracked, and then you have so interest areas. Okay, so there are average interest areas. So if you know that you have tracked binocular, if you've tracked binocularly, you can get average interest area. So this will show you. So there is a small variable definition that comes up over here. So it says list of interest areas in which the current sample averaged across both eyes falls. So if you want to know if your analysis involves the finding out of interest areas, or if you want to know where it has been triggered. Like suppose there were 6 interest areas and you want to know in this particular time period which interest area has been triggered, you can bring this here towards the right, and then you will get this data over here. So similarly you can get interest depending on what you want. Like you want to analyze your acceleration, gaze time, so many things. So essentially the point is target velocity, and these ones in the blue over here are your own individual variables that you have added in experiment builder. Suppose there were more variables that you had added, like accuracy or something like that, they would all come up over here and you would have to move them to the selected variables column so that it would reflect in your sample report. Okay, so now suppose what do I want? I want timestamp is something that is extremely important that you must have, because without the timestamp sometimes in analysis you do not know which particular which particular sample was activated during which time bin, which becomes problematic when you're trying to bin it down. So when I say bin it down, I mean there are this entire thing is for 1,000 seconds, 1,000 milliseconds. Okay, you want to break it down further into smaller bins of time so that it can be analyzed properly in a specific. So suppose I want to bin it down to 20 milliseconds. So then 1,000 milliseconds is broken down into X number of bins of 20 milliseconds, and it's then individually analyzed in a particular bin how many proportion of fixations, suppose. So how many fixations are made towards one particular thing, or if there was a saccade towards a particular direction. So the smaller the bin, the finer your analysis, because you are looking at more data in a very short time period, as opposed to like a grosser amount of data in a larger time bin. That is of course dependent on how you want your data to look like. Suppose you want to analyze for a microsaccade, you have to go down to a very small time bin. You can't look at a 100 millisecond time bin and be like, oh, that I couldn't find a microsaccade. You will naturally not find a microsaccade because you're not looking that closely. You have to go down to as small as possible and then look for a microsaccade. Or if you want just a gross, like there was a bunch of fixations in a particular area, you just want to see where a person is looking at on a screen, you can have a time bin as large as 100 milliseconds as well. It doesn't really matter or distort your data so much. Okay, so like this is, so there are options in here as well. You can create one report file per EDF. So if you want to individually analyze somebody, like a bunch of people's data, what this will do is according to the number of participants that you put in, suppose there are 20 participants, it will give you, if you want to individually analyze the data, it will give you 20 different sample reports. So then you can run the same code on every single one of them to look at what is happening in them. Okay, so then you can have legitimately a lot of different combinations of what you require depending on what your question is and how you want to answer this. So your hypothesis and the required analysis that you plan on doing for it will determine what kind of variables that you choose to come in your sample report. So then you click on next and then it will ask to save, and you save it, and okay. So then it will give you a sample report. Suppose I'll just put in random sample report name. Typically you want to save it, you can save it as a TXT or an Excel file, but you typically want to save it as a TXT file because these tend to be very large files. If there is data for like 20, 30, 40 people, sample report can be up to 4 to 5 GB. That is how big these files are. So Excel can sometimes does not handle files this big, it crashes. So it's easier for you to extract a TXT file and then convert it to whatever is required. Say suppose you're analyzing on R, TXT files work very well with R, so then R can do whatever permutation combination of whatever kind of commands you need to give to that. Okay, so I will extract it in A and it comes out as this. So the point is I can't show you anything on this, but I do have some sample reports on my laptop, so I'll just hook. Is this part clear? Like, is data viewer okay? Like, did everybody get a basic of what happens on data viewer, or should I go over something again? Because this is a very gross overview. Like, this is just something that you need to know for just the amount of what we have covered right now. There's of course a lot more that you can do with this depending on, so I mean, there is no data on this, but if like I could show you how to clip data manually as well. कुछ भी नहीं है इस पे because like you can manually also clip data on like when you can see the visualizations. I would have loved to show you that. Is K16 the only one?
Just try that. That should have enough.
There's only one person's data, I guess.
Okay, this is 120.
Okay. Alright. So this is a video of what happened. So this is a trial view. Alright. What this is showing you is what actually went down in the trial. So it's not even playing. Ah, okay. That's why. Duration. Yeah. All right. So, if huh?
All the views. This view and the video and that. You can explain all the views.
Yeah. Okay. So, all right. So, since we finally have some data loaded onto this, now what this shows you is basically, now if you can see on the very top, there is a bit that says face right over here. Okay, this is also face. So this is a gaze queuing experiment. What happened in this experiment is there was a face shown in the center of the screen, and then there was a dot that would appear at either side of the screen. So what the participant had to do was keep looking at the face and follow the gaze. So if the person, the idea was they would follow the gaze, but their task was to look at the dot. So suppose the person is, the face is looking, and then it makes an eye movement towards that side. The dot or the target would either appear on this side or on this side. So the participants been told find the dot, but chances are that they would end up following the gaze of the face that is being shown in the center. So right over here, there is initially a fixation towards the gaze. You have eye looks towards the gaze, and then towards the face, and then there is D. So this is the distractor, I'm assuming, and is it? It is the dot. Okay, so it is the dot. So then they look at the dot and then they go back to looking at the face. So this is one particular trial for one particular participant, in which so you can have an aggregate of all of this. I will show you that once I am done showing you all of the views. But this is just a graph view of where a particular person has looked at in one particular trial. So if I want like to see an overview of all of this person's trials, I can. So then if I want to look at this, is what they call your trial view. So this is where the person has looked at during the trial with the duration in milliseconds. So the circle is the amount of time they've spent dwelling on somewhere, and the number beside it is the milliseconds that they've looked at something. And इस particular trial में you can see what was happening. These are the two eyes. So they look, it's following the gaze. Illiterates. Yeah. So they look anywhere and everywhere, you know where they're looking at essentially. This will give you a video of what happened exactly. So you can save this one particular BMP. Suppose you wanna like keep this particular trials data outside. You can save it to a different folder towards the end, which is output, which you'll always get when you have this. So the second you save a data viewer session, it makes a different folder altogether saying this particular data viewer session. So in that you will have different folders that will automatically come up. So in the output folder, this is the sample report that I just made, even though I'm pretty sure it'll be empty. But now now that we have data and I extract a new sample report, now there should be more, there should be like data points in it. So if you want this, it can keep this small BMP over here and you can save it. What you can do, but I won't save it here. What you can do is also like make a different, so you can save it in various different formats in different locations. Yeah, so you can also save the movie, like movie as in this entire video, to your same area where it's being saved. Like you can decide where you want to save it and put it there. So now over here it says default interest area set is empty interest area, which can be set depending on your trial. So suppose if I open this and okay, so over here it gives you different details again. Why is it empty?
You have to load interest areas.
You have to add interest areas onto this. Okay, cool. So what you can do is over here, suppose you want to add, and suppose this is an empty interest area like this, and you realize that, oh, I haven't really put interest areas on that. You can go into experiment builder and you can make an interest area set and you can load it onto this. Simply just add a display screen and open this.
You can directly use the gaze to source file.
Oh heck yeah. Interest areas are already made.
Yeah, just make the template and show it.
Okay.
Show the labels and everything.
Alright. So, alright. So this is the experiment that I was talking about. So this particular interest area has been set as D, where the dot appears. So I'm assuming that this interest area is linked to the appearance of the dot. So in whichever direction, and this one is named as T, so that's your other one. So wherever the dot appears, this interest area moves along with the appearance of the dot. So now and this is your interest area for the face. So it has an ID over here by 0, this will probably be 2 and this will be 1. Okay, so you can filter out during analysis, you can filter out a lot of data using these IDs. Say when you're making the sample report, there was average gaze, average interest area ID in one of the options that came up. So you can bring that up into your sample report and you can use it for analysis later on. So, okay, right here. Now I feel like it makes more sense to show you this sample report. Okay, so you have your, अब बहुत कुछ आ गया है यहाँ पे. So what you can do is you can, depending on what you want your emotion. So this particular experiment also tries to understand how emotion affects gaze cueing. So now if you wanna analyze specifically how people were looking or how accurate they were when suppose they were shown a happy face, you bring this thing, bring the emotion to your selected variables, you get your accuracy ke liye expected key, you get your gaze cue towards which direction it is, then you get your depending on what you want. So suppose I want these three things, I will take them and I will put them into R. I will filter my data on R. I will show you R in just a second, but I will filter my data on R, asking it to remove all trials except for the ones that I am interested in. So suppose I want a happy face, so it will only give me data for the ones on happy face with the cue, direction, and if the triggered interest area is the same interest area as the one that was required to be triggered by the cue or not. So suppose I was queuing towards the left but the target appeared on the right. If there was an error, that means if the person looked towards the left regardless of the appearance of the dot in the opposite direction, it will give me all of that as accuracy data. So you can plot that eventually in your R, like to see which how it is affected. I feel like I'm not doing a very good job at explaining this, but yeah.
You can ask people if they have any questions.
Yeah, am I making any sense to anybody?
Yeah.
Are you sure? Because I feel like I'm doing a terrible job at this. No, do you want to take over?
No, it's okay. Continue.
No, are you sure?
Yeah, sure. Does anyone have any questions?
Please go ahead.
If they have, they can just raise their hands and ask.
Yeah, please stop me and tell me if like you need me to repeat something or if you didn't get anything. This is my first time doing this too, so like please. Yeah. Okay, so it's easier when I do it by myself. But okay, so once you have your variable selected, it'll prompt you to save or whatever. So you can choose to save or you can skip it for later, and then it will create your sample reports. I'm just going to name it 2 and have it.
So if we have time, we can explain the interest area. There are two types. The reason the interest area is empty is because in that particular task there are two possibilities, right? The dot can come on one side or on the other side. So if it comes on one side, the interest area is labeled according to that. That this is the target, that is the distractor. Distractor as in it's an empty box. But when the location switches, that becomes the target, this becomes a distractor. So we have two possible interest areas combinations. Okay, so we just save the interest area combination as one or whatever you want to call it, left or right, and load them in the data viewer. So the trials of one type will have one interest area linked to it. The trials of the other type will have other interest area linked to it. So the labels for every location are correct according to how you have designed and how the experiment is shown. If there is time, maybe you can create and show it.
Create an interest area.
Yeah, so the SR, the source file is open, right?
There is time.
This will get saved in a hit.
Yeah, I'm just checking where it's getting saved. Documents.
So you can try to save it again, it will show the same.
Yeah, that's good. Documents untitled.
Ask us. Do we have a mic? Dena, she has.
लाइक यू टोल्ड कि दो इंटरेस्ट एरिया है और वो स्विच होगा जब डिस्ट्रैक्टर आएगा, तो ये डेटा सोर्स से हो रहा है, डेटा सोर्स में इनपुट डाला हुआ एंड देन हो रहा है वो.
तो इंटरेस्ट एरिया को हमने डिस्प्ले स्क्रीन पे ड्रॉ तो कर दिया.
हाँ.
फिर उसकी लोकेशन को हमने उसका जो पर्टिकुलर सपोज आई ड्रू इट अराउंड अ टारगेट, so then I link the location of the interest area to the location of the target. तो जब भी टारगेट मूव करेगा वो इंटरेस्ट एरिया उसके साथ में मूव करेगा. So according to that it switches positions. Does that make sense?
हाँ, that's what I want.
Yeah, that's what you want. Like instead of making 2-3 templates later, it's just doing that for you on its own.
So you have to click in interest area and then go to the like properties of interest area to
Yeah.
make
So you
to link.
have to, I think you missed the important point here. In this case, there are two possibilities.
हाँ.
So if it's not, you can't tell me.
ठीक है, हाँ. In this case there are two possibilities, right? Target coming in the right, target coming in the left. If one is not true, automatically the other is true. So you technically do not need to load interest area templates later and save and do all the hassle that we are going to show you how it works. But you don't have to do this for this particular task. But let's say yesterday's experiment that we were discussing. There are 4 possibilities. There are 4 combinations. When multiple things on a display move in relationship to each other, like right now there's a one target coming, it's fine. But if it's a visual search task, there are 2 objects that you want to come in a different combination. Once it's coming beside each other, once they are diagonally opposite each other, once there is some other contingency. So all these different combinations have to be also accounted for in the data, right? So for that, what you do is for every combination you make a template of interest areas alone. It has nothing to do with the object. Just place interest areas in the locations that you expect the object to be at, of a desired size, like I said, depends on your shape of your object. Then you save those templates. Like Madhulika will just do and show it to you. How do you save a template? You save those templates in a meaningful name, whatever name you want to give them, and the extension is .ias. You can write this down if you want to. Then it identifies that a particular file is an interest area file. That is what IAS means. Then as soon as you save these files, they are ready to be used with the data. So also she will show you how do you import and what does it do to your data. You will get to know what I'm saying. But that is again necessary for experiments which has multiple combination of stimulus types. For something very basic as this, because the interest area can just move left and right, even if you label only one interest area saying the target, even if the other one is not labeled, it's automatic that all other eye movements are going to something else. Right? So it doesn't matter. You need to know whether eye movements within your important trial is going to your object of interest or not. As long as you know that, you don't need any other extra information.
Suppose, like, I'll just show you how you make an interest area template. Okay, suppose like this is just a sample. This is, you have 4 particular locations on which your target or distractor or whatever stimuli you might want might appear. So I'll just name them for easier understanding. Suppose this is your target, this is your D1, this is D2, 3. Now you know ki these are going to move on the screen in random locations depending on the kind of locations you might have allotted to the combinations that you might have made. So now you want to make interest areas around them. So these 3 over here, these are for your interest areas. They have slight shadings on the inside, so you can see it gives a prompt immediately when I leave it on that. Insert rectangle, insert interest area region. So I will just choose elliptical interest area because it is like yesterday Vaishnavi says, it has equal coverage from every side, giving you a slightly better understanding of where your eye movements might be regardless of the shape, so in all particular directions. So you have your first interest area that you've made. Now इसको भी हम लोग बोल देंगे T and we will give it a data. Oh, T, okay, T is already used.
Then this is capital T.
Target IA best. Okay, target interest area. So you say Control C and you also give it a data viewer name because that's what it's going to come up as in data viewer as well. So then iska location, technically you can link to the location. In suppose there was a data source over here, you could have linked it to the location of the target, or if you had a separate column for a interest area ka location, you could have linked it to that. Alright, now then you can maybe copy and paste the same size of this, so that इसी को उठा के you can place it around your other one and name it. Now it gives you this. Then D1 IA, D1 IA, and it has an ID 2 because it was made second. Then you do the same thing. Maybe move it to your next one. Can I?
Better?
Okay, I'll do it.
Okay, now that you have your interest areas around your particular things, what you can do is you can save this as an interest area set. So you can save this image as a screen as an image as well. And what this says is save the interest area set to disk. So you click on this and it will give you a whole prompt. Where do you want to save it? I want to save it to documents में untitled में. यहाँ पे I will save it. So I will save it as interest area set .ias. So this .ias essentially ensures that your thing will be able to pick up, your data viewer knows कि ये interest area set है and it will not have to search. And sometimes it picks up wrong files as well or gives you an error that this file is not available. So by manually putting in, even though you know that you're saving this as an .ias file, by manually putting in the name as .ias, you're ensuring that you have done your bit, so it will be picked up later when you're trying to look for it in the data viewer set. Okay, so yeah, iLink segment files mein hoga and this will get saved. Now I can load this into my data viewer by going to import data and import this particular. अभी आ गया यहाँ पे interest area set .ias. So then you load it. And then you go here. Now there is. Now we'll manually let you edit. So like now what it has done is it has as soon as I loaded the interest area set onto this, you can see यहाँ पे ये नया आ गया. So then they read D3IA, which implies that in that time period D3IA had gotten triggered. Now D3IA is over here. कहाँ दिखा सकते हैं? So this is D3IA. So in that particular time bin, इस interest area में there were looks. Okay. So once you have loaded this into loaded an interest area template into this, you can manipulate your data according to the interest area template. So now when you like get your sample report out of this, you put in since it's already here now, it's filtering data according to these new interest area templates rather than like, because before you had nothing, so it really did not know where to pick up eye movements in, like which area to pick up eye movements in. So now that it has a template, it will specifically pick up eye movements in these particular locations, and you can like look at that data in from your sample report. So if I look at the sample report that we just created, txt file, कुछ भी नहीं है, खाली है.
For that duration.
How is it that I am
What is the duration?
full trial now? Hmm?
Yeah.
Full trial में है.
Yeah, can you check with the eye movements?
There are eye movements for sure. All of these are eye movements.
Yeah.
Okay. If like we look at this particular screen, whatever is enlarged right now, these blue lines are how the participant has looked across the screen. So, ये, as I said पहले कि the small dots were your areas of fixation where they looked for a little while longer, and this is how the participant has looked across the screen, which is very wild considering that there are only 2 locations that you can look at. This participant has had some extremely weird like eye movements, but then that is just to say that a lot of this data comes from illiteracy, but maybe this participant is particularly old, or they were really distracted when the experiment was going on by everything around them, so they had कुछ भी type का eye movements. So in the video, I don't know if you noticed, but there was a period when 2 of the eyes went separate like that. That also happens. It's very curious. To this date, I'm amused when I collect data and I can see eyes drifting apart. The person doesn't really have conscious recollection of the fact that, or that they're not aware that both of their eyes are drifting apart in different directions, but it happens. And I mean, it doesn't harm your data. It's just amusing to look at. Okay, I think it is ready. तो देखते हैं. Yeah, all right, okay. Thank you. So now over here what we have is so what this is giving you is giving recording session label, which is the name of the name of the participant, or however you saved it at. Suppose it was saved by my name, recording session label would come up as Madhulika or whatever it is. Okay, then you have your trial index. So the number of which trial is playing right now. So this is the first trial. So now every trial has thousands of data points. Why? Because the frequency of our eye tracker in that is 1000 hertz. So that means it picks up 1000 frames per second. So depending, it can actually do more. It can also go up to 2000 hertz, but it's not really required. 1000 FPS is more than enough. So every trial has legitimately, so there is about some you can somewhere, if it's not mentioned over here, there's crores of entries in this thing essentially, because depending on the number of trials that you have, utna hi sara there are depending on also how long a participant takes on one particular trial. So in one, so there are participants who take depending on the length of the trial and what they have to do, could be anywhere between 2 to 3 seconds up to 10, 15, 20, 30 seconds as well. So depending on the amount of time spent on a particular trial, the number of entries or the number of data points that you get is varied. So yeah, like I said, there could be crores of data points as well. So this is just the first trial, and और क्या है? What did we do? We
So what do? You do the averaging for all the 1,000.
yeah, essentially what happens is you can so suppose if you were trying to plot, once you bin it, this becomes even finer. So there become particular entries for particular kinds of time periods that you're looking at. And so what you do is you either do a median, so you can do depending on what you want to do with it. If you want to plot say proportion of fixations, or there is one thing that you do is you use a grand event mean. So in that event, whatever points are there, it will average out per participant. Then then according to all participants, it will average out. So suppose I want to look at looks towards a target D1 and D2. What it'll do is it'll average out looks from all participants on the target and give you one single line. Similarly, for all distractors on the and then give you one line for that. So depending on what you want the plot to show, you can have it averaged mostly. But then if like after you've done your whatever sorting or like cleaning up the data, you always will end up averaging data across the participants. So it's all
Then
combined.
why do we need 1,000 hertz? Sampling for 1,000 hertz. We can use the lesser one.
No ma'am, but it's
We have to average it in the end.
no, so it's not actually giving you one gross average, it's every single data point that's being averaged across every single participant. So it's very finely showing you, like if I were to show you a graph, it will show you like in particular time moments how everybody's eyes have gone. Now of course there is error, so it will also show you error bars, as in kitna, by how much variation has some participant might have looked somewhere really far, some participant might have looked really close. So the error bars are what will give you the sort of homogeneity across your data. So if you have a very large error bar, it means that people are not doing the same thing. And to see that, you require that many data points. Because if I just suppose I said कि एक ही data point लूँगी 1 second का, तो उतने में उस person ने ज़रूर target तक तो कर ही लिया होगा, लेकिन उतने में there must have been so many variations that need to be accounted for.
Can
So
you filter it?
we can filter it, but then it's again it's depending on what you want. So like I will show you a visual World Cup plot right now. What is she asking?
Ma'am, can you repeat your question again? About the frequency that you asked. No, because we just had a little discussion, so we would like to clarify about it.
So I was asking that the system had sampling rate of 1,000 hertz. So we are getting 1,000 data points here for each time.
For each second.
For each second.
Yeah.
So I mean, I was asking that after all, in the end we have to do the averaging for each. Each second we'll do the filtering, averaging, and then we do the gross
So-
averaging.
No, averaging is across a certain time span. So itne time span towards a certain direction, what like in this particular location, how many looks have come, that is what is being averaged.
Yeah,
So
so I will
what
just
if a
clarify
person
that.
is making error?
Yeah, so
Then how do we?
she will show you the graph, but what we are actually doing here, so see, having a high frequency rate gives you more eye movements within a less period of time. That obviously everybody understands. Now, what the kind of averaging that she's talking about is within that 1 second, for every few milliseconds, let's say every 10 milliseconds or 5, you can make the bin as small as you want, you can make it as big as you want. You can make it a 100 millisecond bin. What it will do is within that 100 millisecond, every participant's every eye movement will become an average. But if you choose a 5 millisecond bin, then also the same thing will happen. If you have an eye tracker that has a high frequency rate, you will have more data points within that 5 millisecond bin. But if you have an eye tracker of 60 Hertz, then you might have nothing actually. So your 5 millisecond bin has no data versus this 5 millisecond bin has a lot of data. And if you're looking at a bias that is developing over time, these little bins will make a difference, and it will tell you how the bias is growing and in which direction it's progressing, it's positive or negative and things like that.
We have 15 minutes.
Okay.
Nine. Yeah.
Kill me now. Okay, so this is a proportional fixation plots for one of my experiments. All right. So okay, if we look at this particular red line is the target. So how have people looked towards the target? Now, if we see this is the error bar that is for every time point. So like Vaishnavi said, these are all time bins. It's across these bins that it has been distributed. So in this 1000 millisecond, there are, I don't know, I think this is 20 milliseconds ka time bins. In any case, so itna error aa raha hai, that means there is this much variation between a participant's eye movements across participants. So this is data for, I think, 37 or 38 participants. So in one particular experiment that I have done, there is so much variation in just one time bin. Now had the time bin been bigger, then there could have been ye error bar shayad chota aata, because there would be more homogeneity in that longer time duration, right? So that is why you require a greater amount of the more sampling speed that you have, the better it is. 1000 is usually enough for what you need. Yeah, anyway, तो ये था. फिर उसके बाद you have your eye tract, so it is giving you the label of the eye tract, which is right eye, and average interest areas. So because there are because this is not like, there is no particular, this is the one that I just made, the random interest areas that I just made and put, because इसमें actually में कुछ नहीं था. The 4 interest areas in the original experiment, there is nothing coming up in this. Because in trial 1, maybe in that experiment, they did not look into any of the 4 areas that I made and then imported on this. If iska original interest areas were put into this, then you would maybe get looks and it would have an interest area name or whatever. जैसे कि D1IA अगर उसमें लगाया होता, then it would have come over here. Then you have RT, so it gives you the RT. It took this person about 1478 milliseconds to look at it. Then there is a timestamp. कब शुरू हुआ ये experiment, कब trial शुरू हुआ. Then you have your emotion, gaze, cue and accuracy. So it's undefined at the times. Yeah, the timestamp is undefined a bit. Okay, anyway, so the accuracy says incorrect. This person in any case made a wrong eye movement towards the opposite direction. Then so they probably ended up following either the gaze of the cue than actually looking at the dot where it appeared. So this is just a couple of variables that you extract. Now when you put this into R, then you can filter on R depending on what you require. So I'm just going to go ahead and check this.
I think we have some time. Can you go over this?
R?
The Saccard and the fixation variables. Just explain them.
In this or in R?
In this. Because right now we have not discussed any of the variables particularly. So maybe Saccard latency, fixation duration, all these.
Okay. Okay, so a couple of variables that we usually look for. One of them is the very basic one, or that something that I like the project I just showed is proportional fixations or fixation duration. Where does a person look at for how long? So what is a fixation? A fixation is a sustained like a sustained look towards one particular location. So suppose when at the beginning of most experiments there is a cross, right? It's called a fixation cross because people are expected to look at it for a certain amount of time so that you ensure that their attention is in a particular location. So fixation is a sustained eye movement, is a sustained look towards a particular location. Now what you do is if you want to know what has caught, what has directed somebody's attention towards somewhere and then caught their attention, you look at fixation. So like for how long they have been looking at a particular direction. Another variable that you look at is Saccard latency. So since the appearance of the stimuli, how long has it been since you made an eye movement towards that? The speed of, you can also measure the velocity of the Saccard with what kind of speed that you made it. You can, depending on different factors, you can also measure acceleration. Does your Saccard become faster across time periods or does it slow down across time periods? Then you have Saccard accuracy, of course. Is it the correct Saccard after all? Did it fall in the location that you wanted it to fall in or not? And then, yeah, what else? The Saccard amplitude can be measured, like how big was your Saccard. So Saccard can be between two small distances like this also, like suppose there are 2 points, you can be making a straight Saccard towards it, a curved Saccard towards it from a different location depending on, maybe you saw like something flashed over there like a momentary cue and your Saccard curved because of that. So then you can measure Saccard amplitude as well. Then Saccard angle, so towards which angle the Saccard started, like it just because a thing is appearing horizontally does not mean you actually always look towards it in the 90 degrees. You could be looking at it in any particular other angle as well. So you measure Saccard angle, then Saccard direction, of course, Saccard duration, how long it takes for you to make, how long the Saccard lasted for. These are all the interest areas. Then label, blah, blah. Yeah, I think this is all for Saccards. Next fixation also you can measure कि इस Saccard end होने के बाद where did the next fixation go. So sometimes depending on your experiment, it's kind of important for you to know कि even though, like suppose there was a target and a distractor came, your first Saccard went to the distractor, but then after that where did your next fixation occur? Did you go back to the fixation cross or did you go to the target after that? Where did you look after you were distracted? Something like that is something that you could be studying, so you can also get that data from here. Then previous fixation का data भी आता है. Before your Saccard ended or before you made this Saccard, where were you looking? Suppose you made a Saccard to like the distractor. Before that, were you already at the fixation or were you looking somewhere else? Did you come to the distractor from somewhere else? All of that can be found out too. So previous and next Saccard. फिर उसके बाद you can look at fixation report perhaps to see what needs to be. Current fixation can be found for how long you were fixating, where you were fixating. इसके पहले last button released. Okay, so a lot of things that you can do is sometimes when you give a button press, okay, you can after that where did you fixate? After I gave my response, where did I look at? This again. So it really boils down to what you want to look in your, what is your hypothesis, what is your research question, and what is it that you want to understand. Depending on that, you can get all sorts of variables and then analyze your data accordingly. So your current fixation, your next fixation, from that current fixation, then the previous fixation. All of this is contingent to the time period, of course. In that particular time period, whatever it counts as current fixation, uske relatively pehle and baad mein kya hua, that's what it's talking about, not like the entire thing. Okay? you can decide your own trial variables, by the way, over here of your particular distractors. जो भी तुमको नहीं चाहिए, you can discard over here, because then you don't actually have to sit and like put your own variables into the sample report manually. You can just sort of set them over here, and that's what they will pick up in the entire thing. Because sometimes while making an experiment, it's easier for us to put in a lot of data columns in the data source, so that we have a assurance कि ये सही है. But when you're going to analyze the data, you don't really need that many columns. उसमें से कोई 3-4 ही चाहिए होगा, because हमने लगाया होगा ये type experiment है, ये है, वो है, वो है. So you can eliminate all of those in the beginning only and be like, okay, these are the 3 that I need, and I'm going to only move and work with this. Okay. Then interest area report. So interest area report will give you data solely about interest areas. So there are certain types of analysis that involve only understanding interest areas. So depending on that analysis, it's slipping my name, it is called divergence point analysis, I think. There is in which you require interest areas and only interest areas, because उसमें से ही पूरा you will do the analysis. So depending on that, you can also, so you choose what you want. You basically like pick exactly what you need and you make your own dish out of it. So like this gives you your fixation percentage, like this particular one in a particular interest area, कितना fixation था, कि सबसे ज़्यादा across all trials where did the person look. It could have been the trial, it could have been the target, could have been a salient distractor, could have been anything else. कि in this particular interest area they had the most amount of fixation percentage, then fixation count, etc. So this gives you all of the details with regards to all the interest area, whatever possible data it could have had from the interest areas. This particular report will give you that.
What are your multiple interest areas?
Per interest area it will give you the exact data that you want. So suppose तुम्हारे पास 4 था, तो उसका 4 column आएगा, and every one of them will have a separate row of like this. Or more accurately उसका 4 row आएगा, and then like so suppose there was interest area 1, it will give you all of the data, then interest area 2 will give you all of the data, like that. So then you can manipulate it to look however you want it to look on the software that you use to analyze it. Like R will let you convert rows into columns and columns into rows. So you can do whatever you want. Okay, so it's just sort of like, so if we see this person's eye movements, this is extremely interesting. But I'm guessing these two are fairly accurate. The niche wala, these two are fairly accurate for the like the location of the target and like the ye. So this is how that person made eye movements across the. Okay, that's khatam. So then, yeah. That's about it from data viewer, where you, that's about it from data viewer. Like you also get time course analysis. I feel like maybe I could talk about this as well. So time course analysis is across, so this will give you like, this will give you exactly what you want in a particular, so right, we were talking about bin interval, right? तो एक particular time period में, अभी अगर full trial period है, एक trial 10 second का है, so it will bin it accordingly. So it will bin like, is it visible from afar? This? No, right? Yeah. So okay, so now it gives you this particular, you can have all of your interest, whatever you want. So suppose you want your average sample, blah blah blah, bin time, bin duration, eye tract, ID of the interest area, etc. you can get, and you can put it here, and then this will give you a time course analysis. Essentially you can directly take this and put it into a into R or something and plot it immediately, because this is giving you the kind of data points that you want, except you're not actually having to filter it out from a sample report. This is just directly giving you a prepared product to make a plot out of it. So this is 20 millisecond bins and 2000 bins he dega. So even if the trial is like 10 seconds long, it will only actually give you 2 2 seconds का data, the initial 2 seconds का data, which is why you need to then set your interest time period up properly if you're trying to take out time course like binning के लिए time course analysis का data. Alright, so then you can get like put in your interest area that is used for calculation. So if interest area that is used for calculations, you can mention, specify over here तुमको कौन सा interest area में चाहिए, like which all ones should be included in this particular report. So you can give it over here. So suppose you want one, what did we use? We used D1 IA, comma D2 IA, etc. So you can put it that way, and then it will consider data in those particular interest areas. So then you can give it across all samples or across on-screen samples depending on what you want. Then data selections is all samples and fixations and saccades. Then exclude samples during saccades and exclude samples during saccades and exclude bins that contain non. So this particular data selection bit is depending on what you want. So suppose you want only fixation data, you can remove all data that might have accidentally fallen into that interest area bin while somebody was just wandering across the screen. So in suppose a searching experiment, you are searching, you're making many saccades. So you might have made a saccade that crossed an interest area, but you don't want to include that because you want to look at the fixation. So you can avoid taking those looks at that particular interest area completely by excluding this, by taking this option of exclude samples during saccades. So mostly depending on, again, how you want it, you can put it over here. So then you get you can choose this and you can move on, and this will prompt you to make one. I am not particularly making one right now, but then again it will ask you to save it, and then you can save it and then use it accordingly in your analysis in R or whatever. So I don't want to save this, I'm not going to save this. Cancel. Okay, where, yeah, I think I went. So then this is okay. So these are toggles that will help you to see what you want to see. Okay, so suppose you want to see fixation events. Now यहाँ पे this is a fixation event. This particular, I don't know if it's visible. There's a yellow line that showed up right here. Can you see it? This yellow line showed up. So this is one specific fixation event. So in trial 37, this saccade that lasted for 359 milliseconds, that is highlighted. Now, if you want to specifically find out saccades across or across participants or across trials, you can actually individually look at them. Now, this is your.
Can we switch off the gaze and we just make the saccade fixation? Just switch the toggle off.
इसमें but in any case we don't have this. What do you not want?
The sample points.
These points?
Yeah.
How do you get into that?
No, there's no issue.
Oh. Achha.
Now we can see.
Okay, so this is in one particular trial. Like if you look at it, this also gives you the direction कि कहाँ से कहाँ देखा. Can you zoom into this? Okay, so this gives you the direction. This saccade began from here, but then it ended over here. Then there was another saccade that began, but then ended randomly in the middle of nowhere. But there was no fixation. Over here there is a fixation, however. So you can look at a lot of data. You can visualize it according to what you want to find out. I feel like I've said that 3 million times today according to what you want to find out.
Numbers still milliseconds?
Yes, all of the numbers are still milliseconds. That's just how long they have looked. And all of this total मिला के इसका कुछ तो value होगा. कितना ये? So like suppose, so there is a really thick one over here, which must have been like the most important saccade of this entire trial. So you can look at that like that. Then you can also toggle blink event visibility. Right. So if there are blinks, what happens is that when a person blinks, their eye automatically moves downward. Alright. So then you can find, agar यहाँ पे होता blink in this particular trial, there would have been a saccade or a eye movement that would have gone down and then come back up. Usually people just exclude blinks, so then you can toggle using a particular. Oh, we're not even looking at that. Yeah. So this particular ये जो यहाँ पे है, you can check for blinks. So sometimes whose presentation was it? They were saying कि you blink more. Amitash sir was it? Yeah, you blink more when you're like not liking a conversation is what he said. When you're under greater cognitive load, you blink more. So depending on if you want to analyze blinks, you can also see blinks. You can toggle. Most often people ignore blinks because you can completely remove blinks from your data when you're analyzing it. So if you don't want to see it, you can just toggle it off. Like नहीं देखना है तो उसको बंद ही कर देंगे तो वो दिखेगा भी नहीं. Then उसके बाद you have your, so this is like your sample visibility. Turning it on and off will show you exactly how it was looked at, whatever was looked at. Then you have message event time. Okay, cool. So even though this was like, yeah, so this pretty much covered all of data viewer. I feel like data viewer is so user friendly that it gives you exactly what you want without working a lot for it. Like because ये पूरा sample report वगैरह combine करके दे देता है. So you just need to know what your variables are. You just need to be clear with your hypothesis. At the end of the day, it comes down to if you don't know what you want to measure, or if you don't understand the kind of variables that are required for you to be able to make a certain statement or to answer your hypothesis, this entire thing that you've done becomes pointless. Because अगर तुमको मालूम ही नहीं कि तुम्हारे क्वेश्चन के हिसाब से कौन सा वाला तुमको 3 वेरिएबल चाहिए था, and you ended up analyzing so many other things but those 3 things you left apart, then it doesn't make a difference at the end of the day, right? So the only thing that I will say is data viewer, the more you do it, the easier it will come to you. But one thing that I feel like somebody should have told me also when I started out is that know what you want from your data, because data has multiple things that can mean multiple things to different people. So ensure that you know what your hypothesis is, what your dependent and independent measures are, how they might interact with each other, and also always try to have an image of what your data finally might look like. Try to simulate कि my data might give me a graph that might look like something like this. So then you have an idea of where ऊपर नीचे क्या हो रहा है, कहाँ जा रहा है. If it doesn't look like that, okay, hypothesis can be false. लेकिन ऐसा ना हो कि तुमको पता ही नहीं चले कि तुमने क्या बना दिया and you're like staring at the graph. The graph is not going to talk to you. You have to interpret it. So at the end of the day, know your hypothesis, know the variables that you require. Everything else on a software like this can be learned. And I am sorry for this presentation. No, but if there are any other questions, if anybody else has it. Like any questions? No? Okay.